So my name is Yaqing. Thank you for having me here. It's a great honor and a pleasure to speak with you. My presentation today, well, one thing you should know about me, I like to take challenges. It's approved in two facts. First of all, I'm up and running 9 o'clock on Saturday mornings after a whole week of work. So that's one challenge for me. I'm not a morning person. Secondly, I was practicing the presentation yesterday and the microphone just went out. Hello, hello. Hello, hello. Sorry about that. This one. Okay, yeah, this one works. Okay, sorry about that. The second is the title of the presentation is really difficult to pronounce. It's Practicality of Creativity. So I tried to make it fun for you guys today. I know you are all very, very technical oriented, and I want to focus the presentation today on the business aspect of it. First of all, a little bit about Omron. So we are a Japanese company that's about $6 billion in revenue. We have about 4 business divisions, and where I come from accounts for about 55% of our business, which is the industrial automation, which is the upper right corner, sorry. We have robots, light curtains, safety devices, machine controls, visions, and everything you can think of for manufacturing world. To give a little bit of perspective, the world's largest company, Walmart, is about 600 billion. And we're about 1/100th of that size. And a company that you guys know aware of in Texas is Texas Instruments. They're about $20 billion, just to give you a little bit of perspective. And a little bit more about myself. I already mentioned my name is Yaqing. I'm originally from the world famous city, Wuhan. I was born and raised there from 1985, and I studied software engineering from the Wuhan University over there. In 2008, I moved actually to the Netherlands, and I know there are European teams online too. If there's anybody from the Netherlands or north of Belgium, goedemiddag. I lived there for 14 years. I did a business information system study and the MBA study at Erasmus University in Rotterdam. From there, I did a consultancy work at a financial company called Deloitte. And about 5 years ago, I joined Omron as a salesperson for industry automation solutions. In 2021, my company moved me over to Dallas, and I am now leading the strategic business development team here for Omron Americas. I wanted to talk a little bit more about a small country called the Netherlands. They are about 1/16th of the size of Texas. So I found a map that put the Netherlands in the middle of Texas. So the country is not very large in geography. However, it is ranked as the 5th most innovative country in the world. There are few innovations from that country that you might not know of. Some of you might know about the tulips or the windmills from the Netherlands, but they are actually a country with great innovations. So if we think about the compact discs and the Bluetooth and the Wi-Fi, and now what is impacting the world a lot is the lithographic machines. They're all coming from the Netherlands. So that brings me to the main topic of today. All you guys have are great solutions, great technical, fun solutions. How do you actually make those solutions become a profitable business? I think we have a lot to learn from the Dutch companies and the Dutch people. So that's what I want to bring to the presentation today. For you guys, why do we innovate? I think we innovate to solve a problem in a smarter way. And originally, Boston Dynamics designed this very cute pet robot that looks like a yellow dog, and it created a lot of internet hypes. But only until recently, this company started to profit. Why is that? It's not only useful to have your company sustainable if you have a cute solution. You need to find or define a problem or the application or the industry where it can be applied into. Until recently, that they found out this cute pet robot actually can go into dark, dirty, human environment to do the jobs that we as humans do not want to do. Because it has legs, it has eyes, it can do inspection. So one of the applications they found right now is subway inspections. So this is a great application, finding the problem for the solution you have created. In terms of Omron, which is going to be the main product we're going to be talking about today, is a mobile robot. It looks similar. It has wheels, it has scanners, and it can drive around. But what is the difference between the Omron robot with the pet robot that created by Boston Dynamics is that we define it as the main tool to transfer materials. However, this is also not enough to just sell the robot. So what I want to bring to you today is how do you or how do we define a problem when you already have the solution? You have created a robot that has functionalities, and how can you make it sellable or appealing to your audience or your target users? There are a few things for you to consider. For us, as Omron, we always consider what is the industry and what is the segment. We mainly operate in the manufacturing world. However, we also have customers that has a warehouse that is attached to the manufacturing side, to the plant. Sometimes for food or for pharmaceutical companies, they need to test the product. So there is a lab next to it. So there's lab automation that we could also take a look at. And all these have different environment and criteria. So, and another question you can ask, how is your solution could be applied to the problem is how the problem is currently being done. So that comes what your strength and what your unique selling points are. Those are something interesting to think about too. For us, most of the tasks are done, because we're in industrial automation, a lot of the tasks are currently done manually. That's actually the best area where we can apply automation. But there are also automations that could be already in place, so you just need to improve it. Then you need to identify what problems the automation solution actually still have, so you can create an improvement. The last I already talked about, what are the key requirements in the process and environment? For example, in automotive, which I have a case study later on, there's specific industry standard, safety standard, procedure standard that you need to apply to. For food and commodity, for example, and for life sciences, we have FDA in the United States that we always have to comply with. Also, for semiconductors, for example, you have clean room, different levels of clean room requirement that you have to comply. So having this kind of things in mind, I have 4 case studies that I want to go through with you today, and each of the case study hopefully to answer some of the questions, and you will see all those 4 case studies actually use one same type of product, which is the mobile robot, but they're using many different ways. So the first, I'm gonna go to this video here, is what you can see, first of all, is this little robot at the bottom. That's the Omron product. And what goes on top of it is the customer design. And I'm gonna go to this video here. And I didn't play the voice. I'm gonna have a voiceover of this. So what you're seeing here is the environment of semiconductor manufacturing. And you see 2 guys that are in a clean suit, like in COVID times, but it's actually because of the production requirement, there shouldn't be any dust or any dirt on the wafers that they're producing. That's why they're wearing those kind of suits. And I want to go to the part, and you see this guy in the back, he is pushing the cart. So that is part of the problem, how the task is currently being done. It's done manually. And what we have proposed a solution is something that looks like this. So what you can see is that, first of all, it has a specific design on top of it. And this solves the problem of people manually pushing cart in a factory. It also solves the problem that it eliminates the number of touches from the human beings to the product. So all you have to do is to load and unload and register the parts that is being transported in the environment. And what you can also see here, another challenge is in the back, where we saw there are people in the environment. So there's another requirement for the robot to be able dynamically navigate through a very dynamic environment without being stuck too often. So those are the things you have to consider how you want to design your product and what problems you have to solve. And if I go back here, the next case study is in the automotive environment. And I'm gonna quickly pause here. So what you can see, oops, is this is at a company called the Group Antolin in Spain, I believe. They produce car seats. So these are the parts that are for the passenger cars that you sit in. And what you see the application here is again the same product, a mobile robot, but on the topper it's different design, it's different mechanic design. And what we have implemented is a design that is directly interacting with the conveyor belt. So what is coming down of the line is the product of the seats. A collaborative robot is grabbing the part from the conveyor belt and put it on a mobile robot and transport it to the next spot. In this case, there are a few things that has to be taken into account. First of all, is the very strict safety requirement for automotive industries. And secondly, automotive industries has very high and tight throughput time. So automation actually help with that. If you have so there is a very strict support model that needs to be applied to this type of applications. The technology has to be super reliable so that there is no line down scenarios. We used to have a customer that flew a helicopter to our factory site to just get one part to ensure that their line can be continuously running. So this kind of things, that's why for this customer, they chose the Omron product because we have very reliable safety technology and the navigation technology and everything around it. This is another example that I wanted to talk about. Is there anything else? Yes, there is another part that is a bit later at a video that you might be able to see, is that there is a vision system, a camera that is somewhere attached to the conveyor belt. So once you have the product from the line, you can actually use the vision system to inspect if there's any scratches on the parts. And for that, you can register the part. And once the robot arrives at the next station, you can say part number 3 in the middle is a damaged product, so throw it away. And in this case, it creates the whole traceability of quality of the products throughout your factory lines. Going into the next one. This is another very interesting example, is in the warehouse environment. What is the pain point of the warehouse, of the warehouse environment differently from the other 2 industries that we talked about, is the long walking distance for the associates to pick orders. The reason for that is in warehouse environment, everybody orders something different. So you guys might order a type of thing from Amazon and I might be order something else. And currently that's all done manually. And the warehouse can store about tens of thousands of different products in the inventory. And it takes intelligence to manage those inventories correctly. And it also takes space to store those inventories. So what you're seeing here is, again, a mobile robot that has a specific design that looks like this. So each of these totes would be storing a order with a QR code and with the order management system for you to pick, to show you where to go to pick up the order, which order to pick, how many you need to pick, and then register it according to the system. So in this case, the warehouse, again, has a very dynamic environment because all the shelves and all the forklifts and all the people could be running at different areas. that requires a very high reliability of the navigation of the robot, which is the strength of the Omron robot. And something on top of that is what I actually initially studied for my bachelor is software engineering, which is the intelligence of managing the orders and a path control and traffic control, battery management, and everything around the robot. So this is something, again, you design a robot that has a specific hardware and a specific features, but how you apply to the industry is critically important. Moving forward, the last example, which is a video that I really liked because it shows the manufacturing process of coffee capsules. And in this video, you see the case erector machine that is forming the box, and then it will put in a plastic bag to the box because it's food-related products, and then it will shape the box into the correct shape. Then the mobile robot will come to the conveyor belt to pick up the box and bring it to the next machine. And here you can quickly, it's not very clear, but if you rewatch the video, is the Nespresso capsule, empty capsules that you buy from the shops. And then it's using, as I said, the mobile robot to pick it up to the next line. So in this case, what you will see is there are multiple robots in the environment. So what is important is how you manage the job allocations, which robot go where. That's again on the software side, not on the hardware side. And also something you can see here, because of the throughput time, the robot is not, most of the robots are docking vertically backwards. But in this case, the robot is going sideways to the conveyor belt. So in this case, it first of all increases the reduces the docking time. So it will reduce the operational time of the robot. So in this case, it reduces the number of robots that will be needed. Because what is driven in this case is the production speed, not the speed of the robot. You want to have enough robot that is able to manage the production volume from the lines. So if you can reduce the operational time of the robot, you can reduce the number of robots. So what you see here is that most of the time the robots are running autonomously, but because of the very tight space, we're actually using magnetic tape to help the robot positioning against the conveyor belt. The last example, that all these examples have YouTube links that you can go back and watch online. The last example, I don't have a video because it's actually a picture that I took from LinkedIn, but I like this project a lot because this again shows you have a solution, but the challenge of the application does not lie on your solution. This is again a mobile robot in black skin, but our team actually spent most of the time in identifying the needed conveyor belt material to transport the tires. So this is in Continental, the tire company, and is transporting the tires that are justly coming from the ovens, so they're hot. And as we mentioned from the race team, the importance of the tires for the cars, there's very strict quality standard for the tires. When it's coming from the line, you have to maintain its temperature, you have to maintain its shape, otherwise it won't be used or it won't be produced according to the safety standard for public uses. So we spend a lot of time designing and identifying the materials that can transport the hot tires without damaging it. And also in this case, you see a lot of robots that is trying to pick up the orders from two different lines. So in this case, how do you manage to queue the robots in a smart way so that it doesn't create a traffic jam? Because if you line the robots like next to the conveyor and the robot cannot get out. So all those kind of things sound stupid, but it's something you have to take into account into specific projects. So these are all the examples and the concept that I want to bring to you guys this morning. Just think about you have a great hardware, you have a great robot, but what is really the application you want to apply? Is there any additional intelligence you want to bring in? Is there any specific industries? Look at the growth of the market, look at what you're familiar with, look at where your passion is. That's where you want your solution to be targeted at. Thank you. Is there any questions?
We have a couple questions from the online members.
Okay.
So the first one is, what makes the Netherlands such an influential place for technological advancements?
My experience living in the Netherlands, I think they're very structured people. Like I said, usually they like to identify the problem very clearly. So that helps you to innovate because you are trying to solve a problem. You're not just brainstorming about something. So I think, and they're very hardworking as well. So I think all those good qualities make the Netherlands a good country to innovate.
Cool. Are these robots affordable and are they able to reduce the operational costs of an industry?
Definitely. So we have a lot of customers in automotive industries, for example, Toyota, BMW, Autoliv, all those companies actually applying our robot in their factories. And there are two sides of the cost that you have to think of. One is obviously to replace the manual workers pushing the cars around, but also there's intangible costs about improving the quality, liability, and the traceability of all the products. And those things you have to take into account as well. And robots never take a sick leave, so you can run 24/7.
Cool. Thank you so much for the presentation.
Thank you.